So, welcome back. It's been a while since I was last posted a video. I believe the last time I gave an update was on the 3D printer and actually kind of building a few updates around that. Still a bit of work ongoing with that. Taking a few, took a break from it, and then a few things arrived late, and etc. etc. So that's taken a little bit longer than anticipated. So in the meantime, I thought I would just give a little overview of a project I just recently finished. So if you've seen the thumbnail or read the video post, you probably have a pretty decent idea as to what this is about. But to give a bit of a backstory. So I am looking to do a few projects with LEDs and light control, and so I decided I would try and make a RGB signpost with the theme of the gym I go to in it, and just do some very basic control with it as an introductory project for LEDs. So the point of this really is a recap as to how that project went, some of the easy stuff, the good things about it, and also some of the tricky stuff that I think are kind of good considerations to have before you start off. So, how do we control LEDs? Well, this here is an example of a red LED. Now, what's interesting about LEDs is they work a little bit differently to your standard light bulb. So, LEDs have a positive end and a negative end, meaning that when you connect it up, let's see if we can zoom in just a little bit. Yes, so an LED has a positive end and a negative end, what we call the anode and cathode. So basically, LEDs function off what's called direct current, DC current. So LEDs work only with this DC current. Now, LEDs work a little bit differently in terms of dimming and brightening than other devices. So typically, if you were to plot what we would say voltage, kind of like your power going to it, and we'll just put time across along here. The brightness of an LED isn't determined by how much power you put into it, how much voltage it is. It's determined by how long you leave it on. So what happens is we will turn on this LED for a fixed amount of time, and if it's always on, so if we have our LED going constantly on the entire time, right, we will see the LED at full brightness. Okay, lost focus slightly, apologies. So, as I was saying, for an LED to be fully bright, we would need to be on all the time. So this is an Arduino, and I am just going to plug this LED, one end of it into, I'm not sure if I can zoom in on this even more. That's what I do. So basically I'm going to plug this into power source, which is 3.3 volts and ground. Now hopefully there's enough battery in this for it to work. There we go. So, the way it's plugged in now is it is always on. That flickering is because I'm powering this with a battery bank, just because my laptop's away and it's kind of hard to get to. But you can see here it's turned on all the time. And so that's what we have here. That's our brightest setting, where there's no off time. Now, if we want to dim the LED, we don't reduce the amount of power going to it. Well, we inadvertently do. This thing's having a bit of a field day. Focus. So what we do is we adjust how long it's on for. So if this is, I suppose, as much power to turn it on, this is off. 0 volts, sort of, if you can imagine. So imagine what we'll do then is we will turn it off for, say, half the time, and then turn it back on half the time, and then turn it off, etc., etc. And say this is, we'll say from here to here, say that's 1 second. If you have it off half the time, that sort of gives you a 50% brightness. That's how you reduce your brightness. And likewise, we can increase it, the time on this direction, or we can have it this direction exactly. And if we have it on more, that increases the brightness. If we have it on less, that decreases the brightness. So hopefully I might be able to do a quick demo on this here. I have a program running on this whereby it does exactly that. It decreases the time at which it's on. And if I've done this correctly, then you see there, we have our LED turning on and off periodically. And all I'm doing in this little sketch is what I mentioned here, where I'm just increasing the amount of time it's on and then decreasing the amount of time it's on. The resulting effect is an LED that we can control the brightness on. So next up, I wanted to start expanding that out. So this, we're just controlling a single LED with one color. And if you want to expand that out to control multiple different LEDs with the same color, it's the exact same principle, but a few things change. So here we have what's called an LED strip. This is a very basic one. This is literally just, there's a few different varieties of these. This is the very basic RGB one. There are the ones that are sort of individually addressable, so you can kind of control individual LEDs. This isn't one of those. This is just controls all of them at once, so it's all just multiples of this. So the primary difference between these two, besides the fact that one is kind of flat in the tape and one is a dome shape, is the amount of power required to turn this on. So this requires very little power, I think maybe about 3 volts, something around that line. This, on the other hand, requires 12 volts, 4 times what this can provide. And this is when it starts getting a little bit tricky with these LED controllers. So, as we've just said, the issue we have is that our standard Arduino can't output enough power to turn on a full LED strip. The reason being is, well, one, this requires 12 volts, and then also the power requirement on top of that 12 volts is going to be quite high depending on how many LED strips you have, and these little microcontrollers aren't built to handle that. You'll fry stuff in here. So that's why I need to create sort of an LED driver circuit. So an LED driver circuit is just simply a way of controlling the high power that we need in the same manner that we were using before with the Arduino. So basically, to do that, we're going to use what's called MOSFET. MOSFET is just a sort of basically a very fast switch you can use to turn on and off power. So a MOSFET has 3 different pins called gate, drain, and source. This is, I suppose, what it looks like. These are what the different pins correspond to. That's what you might see on a circuit diagram. This is kind of confusing, but the main thing you need to remember is that you have gate, drain, and source. Okay, so though I just do a very quick circuit diagram that we'll be following. Definitely makes wiring things up a lot simpler when you have a diagram. I'm not going to go into the ins and outs of how these MOSFETs work. There's a lot more videos out there with people who know a lot more than I do on this. So I'll be kind of, yeah. So basically, we're going to start off with our Arduino pin, in other words, the one we want to control this with. So that'll be one of our PWM pins, which is, for example, I don't know if you can see it here, on the actual Arduino, it's the ones that have the squiggles next to them. So basically, we'll have our Arduino pin here. PWM pins. This is the same pin we were using to control it earlier. Now we'll have that connect to our to the gate of our MOSFET. So that's our gate. The middle pin this will be where the actual power is coming from, the control for the LED strip. So I suppose of note, it'll be going to either the red, the green, or the blue one. It won't be going to the black one. That's important to note. So that's going to be going to our LED strip, R, G, or B. This last pin here, which is our source, this will be going directly to ground. Now, that's our basic circuit, but it's still somewhat incomplete. To make this work, we have to ensure that the Arduino is ground, GND, that also is connected to the same ground as that, okay? Same symbol, same ground. Otherwise this won't accurately detect the changes and it won't work correctly. Now the very last thing we'll need, and this is it, after this it's quite straightforward, is we need to put a resistor between this pin here and ground. I won't get into why, but basically if you don't, the pin might turn on accidentally. The lights here, this gate might get opened accidentally, so we're just going to put a resistor there, have that connected to ground, same ground as that one, and generally we use 10k, 10 kilo ohms. So that's our basic circuit there, so fairly straightforward, and this is how you control 12 volts of the red, the green, and the blue LED. Now, the only other thing we need, which I almost forgot, is the actual black wire of this here, this LED strip. That needs to be connected to 12 volt, so we'll just do so this is the general wiring we need to have for our schematic, for our controller. So I'll do a quick mock-up there is what we need. Okay, so now we're just going to quickly build this circuit. So we start off with our MOSFET right here. It's, I suppose, put into the breadboard here. Now the first thing we're going to do is connect the MOSFET to ground. Right, we're going to make this line here all ground. So to power this initially, we're going to use this 12 volt DC jack that has these kind of connectors on the output. So those are going to go into our live and ground. So again, that's connected to the rightmost pin of the MOSFET. Now, the output of this MOSFET is going to be this middle pin here. And if that would ever go in, perfect. And now I'm going to connect that to one of our 3 colored pins here. So I have a green wire, so I'm going to connect it to the green output of this. Now the black pin here, I'm going to connect to the 12 volt of the LED strip here, as so. Now to actually control when this gets turned on and off, we're going to plug the leftmost pin to the Arduino. As you can see here, see if I can get that all in shot, perfect. So that's now connected there. And as we said before, we need to connect the rightmost pin also with a 10k resistor to ground. Now, very last thing I'm going to do is I'm going to power this Arduino with this same power source to avoid multiple wires. In general, so we connect the ground of the Arduino to the ground of everything else. That's really important. You could, if you were initially testing, which I would recommend the first time you set this up, don't power this don't power the Arduino with the same power supply, power with the 5-volt power supply, and then have this all powered separately. I'm just doing this because it's easier and I know it works. So I'm going to put the in of the Arduino into the 12-volt power supply on this. So now let's give it a quick test run. So as you can see here, I'm just going to be plugging the standard 12-volt plug into this 12-volt jack, and hopefully, if I'm not mistaken, here we go, we have our LEDs. And I'm running the same code it was before, where I was fading the LED on and off. So I'm changing the brightness. Exact same principle, fairly straightforward I think. The only difference is we are now doing it with 12 volts. So that's the so that there is the basic theory, and actually, to be honest, you would just do this 2 more times to control the different colors. So for example, if I take this now and I plug it into a different color, say we'll do the blue, that now controls the blue. So again, you would just replicate this 3 times over, the exact same configuration, and voila, you've controlled a basic RGB LED strip. So once you have your circuit finalized, you would maybe put it into a more of a long-term solution like this breadboard here. But this is the exact same circuit we saw before. We have our 12 volt power in jack here, and we have our 3 resistors. Let's see if I can get this. A lot of it's glued in place, it doesn't move around. But we have here our 3 MOSFETs. Each of those are connected to individual pins on this Arduino. This is what's called an Arduino Nano. It's the exact same as the larger Arduino, just in a smaller size, so it's more convenient. So yeah, each of these is connected to a PWM pin, I think whatever, pins 10, 11 and I think 3, just they were the easiest to connect wires to. The way I sort of laid this out, in hindsight, it probably isn't the best. It'd be better if I had this, the actual connections going to the LEDs stuck on the sign. It'd be much better if those were layout-wise this side of the transistors, just the way when I was soldering up, it would have made it would have been easier to work with in that sense. In terms of general improvements, I'd maybe try, if I'd done this again, I probably would have switched this around 180 degrees, pointed upwards, because it just means that when it's sitting down, it's easier to access the USB port in case I want to program in different kind of color flashing combinations. Just a bit easier. It's not much of a nuisance as is, though. Biggest watch out with this, though, is I fried 2 of these little Arduino Nanos in the process of making this. The reason being is these 12mm, well, I keep saying 12mm, 12-volt jacks have 3 pins on them actually. And if you bear with me, so this right here, once it gets into focus, is a newer version of 12-volt jack, just one I bought fresh. This one was salvaged from an old component, so it just came in a handier plastic square tubing, so made it a little bit easier. But if you can see here, this has 3 pins. 2 of these pins are ground. One of these pins is the 12-volt signal, so 12-volt power. So the mistake I made initially, and how I fried one of these mini Arduinos, was I had the power connected directly to these MOSFETs and to this, as kind of was intended. However, I had connected the ground initially, the ground connected to, there's multiple ground pins on this Arduino, so I connected the transistors directly to the ground of this, which normally isn't a problem. However, I then connected the ground of this to here, so effectively these transistors were connected to this pin, having to go through the Arduino on the ground. Now, I always assumed frying stuff was more of an issue with the the power supply, the 12 volt, the high end stuff, but also you need to watch out for the ground to make sure that there's a connection directly from the transistors to the power supply. So that was how I fried one of them. The second one I fried because the connection between, I think because this is a reused, recycled pin, that was connected, the actual 2 pins of it, I think there was a bit of damage on them, so there wasn't a great connection between them. So even though the second time round I soldered the ground directly from there to there, and I had this connected from here to here. However, for some reason it still fried it. The way I fixed it was I just soldered the 2 pins, the 2 ground pins on this together. I think maybe there wasn't a great connection between them, or don't know what exactly happened there, but just to watch out on this anyway.
Now, so the video's taken quite a bit longer than I originally thought. I went more into, I suppose, the theory behind the LEDs and the circuit more than I thought I would. Definitely enjoyed it, but consumed a bit more time than I originally accounted for. So what I'm going to do is I'm going to split this video up probably into 2 parts. Try to keep it 2, don't want to drag it on for too long. But before I kind of go into what the next bit will be, I just want to kind of recap what we did so far and the main watch-outs, I guess. So the main points to consider when you're building a circuit like I did there is just to really ensure that no of the power paths, whether that be ground or the positive voltage, pass through the Arduino to get to the transistors. Again, it'll just save you potentially burning out 2 Arduinos like I did. I guess as well, just make sure the components you're using are fully functional and that you don't get any kind of weirdness like I did that blew up another one. So yeah, just make sure your components are all working correctly. Secondly is just to place the LEDs after the transistor. So you can see, I think I mentioned it before, I had my Arduino, then I had the actual connections to the LED, and then I had the transistors after that. Rather switch the 2 around so that you have Arduino, transistors, LEDs. It just makes the actual building of the circuit a bit more easier, but that's a very minor one. The last one is just to make sure that the ground of the Arduino is the same as the ground of the MOSFET or the LED driver circuit. So straightforward enough. I wanted to also just go over a few things. So I've since been looking a bit more into these kind of driver circuits and realized there was sort of parts I could add in that I didn't. So this is the schematic we were using before. The only differences are highlighted in red from what we had, and that is just a 100-200 ohm resistor just between the PWM pin from the Arduino and the actual circuit. The reason for this is that it just limits the current coming from the Arduino. These MOSFETs apparently can be quite demanding, and sometimes the draw is more than, without this resistor, the draw can be more than what the Arduino is actually spec'd for, and that over time will damage it and kind of cause premature wear and death. For the circuit we created, for my application, I didn't add it in afterwards because it's not really needed, just because it's only kind of a test thing, but best practice would be to add this in if longevity is important to you. Another component here is a Zener diode that they connected between the between ground and that just what's it called? Yeah, it's just good practice. I'm not entirely sure what its purpose is, but it's kind of recommended to add that in, so we'll definitely add that in. So that kind of concludes the main learnings from this video. The next video, what I want to cover is more, I guess, the physical design and layout of the sign, how I kind of put it together, any things I would change on that, how I actually kind of stuck the LEDs and everything together. Because there's a few kind of learnings from that I think would be useful if anyone wants to try and make this and make the lives a little bit easier. The second part I want to cover, and this is kind of probably the most value I'd say in this video, would be how to actually handle these cheap LED kind of strips, the ones I've been using. So there's a few tricks, I guess, that I kind of learned. This was hands down the most difficult part of the entire project, and really kind of gave me a lot of grief. So hopefully I have some learnings, definitely what not to do, and hopefully some things that you can do better. And as well, I'm hoping it could be good because I used fairly basic equipment that wasn't really designed for this, so which is probably representative of what most people out there who are thinking of starting this off have. So hopefully give a few tips on that. But anyway, thank you very much for watching, and hopefully I'll see you again.